I'm Mrs. Sal Shami. In this video, we're going to explain the preparation, reaction, and physical properties for alkanes. Let's start. Alkanes. Okay. Simply, alkanes are saturated hydrocarbons. Let's start with saturated. What is the meaning of saturated? Saturated means that the molecule has single sigma bonds. Okay. The sigma bond is considered from strong bonds, which makes alkanes chemically less active. Okay. What about hydrocarbons? Hydrocarbons means that the molecule is mainly composed of two types of elements, which are carbon and hydrogen only. Okay. How can we know that this molecule is from the alkanes family? Okay. We can know it simply from its general formula, which states that CnH2n plus 2. Let's take an example for it. If we have n equal 1, what is the meaning of n, or what is the reference for n? N refers to the number of carbon atoms. Okay, so here if we have only one carbon atom, how many hydrogen should we have to form an alkane compound? We just make 2 times 1 plus 2. 2 times 1 gives 2 plus 2 gives 4. So the formula will be CH4. Okay, another example. If we have the n equal 2, so we have a member of 2 carbon atoms. Okay, let's start to calculate it. 2n, which means 2 times 2 plus 2. 2 times 2 gives 4 plus 2 gives 6. So the formula will be C2H6 and so on. So here, how can we know that this molecule is from the alkane family? Just apply this formula, CnH2n plus 2. Now it's time to talk about the physical properties of alkanes. About the physical state for the alkanes, the first 4 members of alkanes are found in the gaseous state, so they are found as gases in the normal temperature, like what? Like the methane gas, which can be used as fuel in our homes. Okay. While the alkanes, which contain from 5 to 17 carbon atoms, are found in the liquid state, so they will be liquids at the normal temperature, like what? Like gasoline and kerosene, which are used as liquid fuel. Okay. The last type, which contains more than 17 carbon atoms, they are found in solid state, or they are found as solids, like what? Like the paraffin wax. It's our time to prepare the alkanes in lab. How can we prepare alkanes in lab? We can prepare it by a process which is called dry distillation. How can we make this dry distillation process? You just put the salt of the carboxylic acid plus something which we call soda lime. What is this soda lime composed of? It's composed of 2 things. The first one, which reacts with the salt of the carboxylic acid, which is the caustic soda, or the sodium hydroxide, NaOH. Okay. The other thing, which is the quicklime. Quicklime here, it's calcium oxide. What is the function of this quicklime in the reaction? It aims to decrease the mixture melting point. So it's just here for decreasing the melting point of the mixture. Okay. After that, you will obtain your corresponding alkane and sodium carbonate. Let's apply it on a simple example with our tips and tricks. Okay, let's start. Here we have the salt of the acid. The salt of the acid, CH3COONA. Its name is, let's start with the metal, so it's sodium acetate. Okay, here is the reaction. You just need to break this compound before the cool. Okay, and break where else? After now, here. So just make them combine together to give you the corresponding alkane. So it will be CH4 plus, we have here sodium and sodium, so we have 2 from the sodium atom, Na2, we have 1 carbon atom, so C, and 3 oxygen atoms, which are O3. Okay, here we get our methane molecule. Now it's your time to practice another example for dry distillation process. We said that we should take the sodium salt for the carboxylic acid and the sodium hydroxide compound. Let's start before Q and after now. So let's make the ends bind together. So here we have C4H9 plus 1, so it gives H10. So it's our corresponding alkane plus what? Plus sodium carbonate. Okay. Now it's time to know how to prepare the salt of the carboxylic acid through a neutralization action. So you just need to make this acid, this acetic acid or ethanoic acid, react with sodium hydroxide, which is a base, to give salt plus water. So here is the salt of the carboxylic acid that we need to make our dry distillation process. The last part in our video is the reaction of alkanes. How can the alkanes react? They react by substitution reaction, which makes us know this simple statement. Take H off and replace it. Take H off and replace it. So the number of substitutions will be equal to the number of hydrogen atoms. Let's consider methane as our example for today. Okay, we have CH4 plus Cl2. We said that we should take off H. So after taking off H, it will give CH3 and replace it. Replace it with what? Replace it with the chlorine. So it will be Cl plus what? Plus HCl. Okay. The next one, CH3Cl plus Cl2. What is the result for this equation? Take off H, so it will be CH2Cl and replace it with what? With another chlorine atom, which gives us Cl2 plus what? Plus HCl. The next one, take off H and replace it, so it will be CH only, Cl3 plus HCl. The last one, CHCl3, take off H, so CCl4 plus HCl. You just need to ask yourself if this compound can replace or can make any other substitution action. No? Great, excellent. Why is that? Because it doesn't have any hydrogen atom to take off them and replace them. Okay. How can we write this reaction as a total reaction? So here, for substitution of the 4 hydrogen atom, we just need to use 4Cl2 to give us CCl4 plus 4HCl. Here we just make the 4 substitution actions at one time. The second type of reaction is the combustion or the burning reaction. Alkanes can undergo combustion like methane will combine with the oxygen in presence of what? In presence of heat to give us carbon dioxide plus water vapor. Okay. What about the third type of reactions, which is called thermal catalytic cracking? The thermal catalytic cracking is a process that aims to converting the long chain of alkanes into what? Into short chain of alkane and short chain of alkene. Also, it can produce at some times according to the temperature and pressure and the used catalyst, hydrogen gas. So here we have three conditions, which are temperature or heating, pressure, and in the presence of a catalyst. Okay, let's take an example for this process, which states that octane C8H18, after putting it under a great or a high temperature, pressure, and in the presence of a catalyst, it will give us what? It will give us C4H10, which is considered a short alkane, and C4H8, which is considered a short alkene, which can be used in the daily life. The next reaction is the thermal cracking. Thermal cracking for methane considers that if we have methane molecule and we heat it to 1000 degrees Celsius in absence of air, so without air, it will destruct or crack into its components, which are carbon and hydrogen gas. Okay, the last reaction for methane is the action of methane with water. So if you react methane gas with water molecules in the presence of what? In presence of a heat of 725 degrees Celsius and a catalyst, it will produce what? It will produce the following. It will produce carbon monoxide plus hydrogen gas. This mixture is called water gas. Water gas is a mixture that can be used as reducing agent in some industry like iron industry. Yay! It's math time. It's our time to summarize all the equations and reactions that we have mentioned in this video. We just started with the carboxylic acid that can undergo a neutralization reaction in the presence of sodium hydroxide to give us the sodium salt of carboxylic acid, which can undergo another process which we call dry distillation process in the presence of sodium hydroxide, calcium oxide to decrease the melting point of the mixture, and of course heat. Okay, to give us what? To give us the corresponding alkane, which is here methane plus what? Plus sodium carbonate. Okay, methane can undergo different types of reaction. The first type is the burning or combustion reaction in the presence of oxygen and heat, which results carbon dioxide and water vapor. Substitution reaction, which is found in the ultraviolet, in the presence of ultraviolet rays, which react with chlorine or any halogen. Okay, to give us what? To give us alkyl halide or carbon tetrachloride plus HCl. Okay, the next reaction is the heating or thermal cracking, which occurs in the presence of 1000 degrees Celsius and absence of air to prevent the oxidation reaction to give us the components of methane, which is carbon plus 2 hydrogen gas. Okay, the last reaction is the reaction of methane with water in the presence of 725 degrees Celsius and catalyst to give us carbon monoxide and hydrogen gas. This mixture is known as water gas. Thank you all for watching this video. Don't forget to like, share and subscribe in my channel to get more videos. See you